Greeting to everyone, my name is Ong. My final year project is Heart Disease Analysis and Prediction. I developed this project under the guidance from Dr. Sukuma. This project is regarding to machine learning project. The motivation to develop this project is the heart disease that case increase year by year. This project included data analyzation, which is analyzing the data visualization, which is presenting the result in graph form. Data accuracy assessment is to evaluate the accuracy score of the dataset by using machine learning algorithm. The last feature is applying prediction algorithm to predict the risk of heart disease. So according to WHO report in 2018, there are 63,000 heart disease death cases in Malaysia. By comparing to 2017, it was increased by 21%. Besides, most of the citizens lack of self-awareness toward heart disease and lack of knowledge about factors that cause heart disease. So for the system objective, the first one is the project will analyze the heart disease data set and present the result in the graph form. The second is there are two machine learning algorithms like LR, Logistic Regression, and DTC, Decision Tree Classifier, will be used to analyze the accuracy of the data set. For the last is the heart disease rate prediction. This project will predict the risk of heart disease for the user in percentage form and will list out what are the possible diseases for the user. So this is a module diagram for this project. So you can see the first module is regarding to data analyzation and visualization. The second module is regarding to data accuracy assessment. The third module is outcome prediction. So this is the architecture diagram for this project. So you can see the front end is regarding to HTML and CSS. The back end is more about the Python. So the Python Flask will be used to transfer the data their input from the user to the back end, and the back end will return it back to the front end by using Python Flask. The first module is regarding to data analyzation and data visualization. There are three analyses for this module. There are overall analysis, male analysis, and female analysis. For the inner analysis, there are several attributes that are going to analyze. They are gender, chest pain type, fasting blood sugar, blood pressure, cholesterol, number of current reserved by philosophy, and age. So this is the overall analysis of this project. The uniqueness of this project is the graph is building for the SVG graph. It is scalar vector graph. So you can see as you're trying to minimize it, the pixels are still clear. There won't be like the blur issue happen. So the graph is also appear like the UI when you're trying to hide something like the blue bar, or you want to present a red bar, you should be able to do that just like this. So you can see from this data set, you can see that there are 54% red to get a heart disease. For the gender, as you can see, woman is 75% while the man is 45%, and you can conclude that woman has a higher heart disease rate compared to men. So for the chest pain type, as you can see, there are two significant symptoms and high potential to heart disease. They are typical angina and the atypical angina. The rate for typical angina is 73%, while the rate for atypical is 82%. For the fasting blood sugar, we can see that the description showing they are above 126 is signal diabetes. As we can see, for both normal and high fasting blood sugar, there are still hidden potential to heart disease. For the blood pressure, the same thing. For the both normal and high level is they are still have potential level to heart disease. For the cholesterol, they are still the same. Both normal and high level, there are still hidden potential toward heart disease. For the slope of peak exercise, we can see that the downsloping is higher. You can see that 75%, which means this is a significant signal or high potential toward heart disease. While the flat sloping is measured about, this is a typical heart rate, while the upsloping is a sharply heart rate during exercise, but it's still uncommon. For the number of major vessel colored by philosophy, it means the colored vessel is the blood they can passing through. The more the blood movement, the better. You can see that the yellow colored vessel can be considered as significant signal and high potential because it's a higher rate, like 74%. So this is a edge tabulation result in the graph form. Second module is regarding to the data accuracy assessment. So there are two machine learning algorithms. The first is LR, the second one is DTC. So there are two results we are getting for each algorithm. The first is training result, the second is test result. For the inner, we are using precision score, recall score, F1 score, metric, and accuracy score. So when the accuracy rate for the dataset is above 75%, we can consider the dataset is clean and it should be accurate for the prediction purpose. This is a machine learning algorithm patch. So we are looking for the logistic regression. We can see that the trend result for the accuracy score is about 84%. It's almost 85%. For the test result, is almost 84%. So it should be correct, and it was qualified to use for the prediction purpose. For the decision tree, as you can see, it's about 100% for the trend result, and 100% of the test result. So we can conclude that both algorithms are qualified to build a model for the prediction purpose in the last module. The last module, which is the third module, is regarding to the heart disease risk prediction. So in this module, the user are required to enter the age, gender, chest pain type, fasting glucose level, cholesterol, blood pressure, smoking status, and the ML model. So when the user clicks submit, the screen will show the risk score, risk level, and possible disease. So when the disease fall in 0 until 10, they should be considered low risk. When fallen in 10 to 15, they consider moderate. When above 15, they consider high risk. So this is a heart disease prediction patch. So as you can see, users are required to enter the age, assuming the user is about age 47, and it was a female, gender, and the chest pain type is something like maybe typical, and the diabetes maybe no, and the cholesterol level maybe yes, and the blood pressure maybe yes, current smoking maybe yes. And first we are selecting the logistic regression for the first testing. So let's say I click submit. So as you can see that there are 12%, which is moderate risk. So the below will show the possible diseases. Like just now the user had a chest pain, it will show up any possible disease that are regarding to chest pain and some prevention to prevent the chest pain, like the exercise regularly and taking medication advice from doctor. So they are also showing the other like high cholesterol and the high blood pressure, you can see, and the smoking also it will be showing the below. So now we are trying for the second machine learning model, which is the DTC. So let's say the same thing, the user is 47, the same, gender female. For the chest pain is typical. For the diabetes is no. For the cholesterol is yes. Blood pressure also yes. For the past smoking or current smoking is yes. So let's say we're trying for the decision tree, and we click submit. As you can see, when we are using decision tree, the rate will be higher, it's 20, which is above 15, and it should be considered high risk. So the same thing, the below we're showing out the possible disease also for the heart disease. Now the same user wanted to test another result, and he just simply click retest, and he select input another data, something like this, 70 at 70, gender at male, chest pain no specific, diabetes yes, total cholesterol yes, blood pressure, high blood pressure no, current smoking no, and the user select LR model. Let's say click submit. You can see 80% high risk, and the possible disease for diabetes and in prevention, possible disease for high cholesterol and prevention. Yes, so this is the final result. So for the impact and benefit from this project, so this project should be able to provide what kind of attribute that affect the heart disease. Like they were showing up what kind of significant symptom and what kind of attribute which is higher potential toward heart disease. So for the second one, this project should be able to predict the risk of heart disease in per certain form and the possible what kind of possible disease for this project. Yeah, thanks.